the equatorial, the sun-synchronous orbits, which leave a little bit of hole, and that's a polar orbit. Okay. Again, the geo, with some spread around this graveyard orbit, which is a couple of 300 kilometers or so above the northern one. So it's bringing him up, because bringing down is impossible in terms of energy. And now, watch this area. What you see here, it's this Molniya tundra orbits of the Russians, which are these highly inclined orbits, 24 hours. Okay, so that's it.
Thanks. Thank you, Manfred. And now we have a man who is the father of CubeSats from CalPoly. I am so happy to introduce you Professor Jordi PUIG-SUARI, who came from the West Coast, from CalPoly, and so long track CalPoly, Aerospace, engineering professor, faculty advisor, and now, if I understand correctly, you are also a CEO of PUIG. What is a PUIG?
It's a new small startup. I'll give you a little bit.
Very good. Excellent. I'm happy to give you microphone to our keynote speaker on the CubeSats. Jordi, take a mic.
Let me see if I can get the presentation running. There's Jordi. Perfect. So can you hear me? Is the mic working? Great. So yeah, there's this little thing today that I have like a few jobs now. Where's the? Oh, and the laser. So yeah, so I'm a CalPoly. I'm a professor in aerospace engineering. That's where everything started. But recently, because we were watching ISAs and other companies do very well, we decided the only way to compete with them was to become a company ourselves as well. So we started a small company because, hey, we haven't done that yet, and it would be a fun thing. But just a little bit, what have we done at CalPoly? What have we done at CalPoly? We started the CubeSat standard with Bob Twiggs at Stanford. That was in the year 2000, so it's like, what, 15 years ago? Gosh, that's a long time. We've developed some satellites, what we call the CP series, you know, CP1 and 2 and 3, and I think 10 just went up. And then we've also developed a P-pod and worked on launching CubeSats from the very beginning. And now the numbers get really scary when you work on this field, because the numbers are very large. We've launched more than 100 CubeSats, 50 P-pods, 13 different missions, 8 different launch vehicles. You work on all these very, very diverse environment, which is unusual for the aerospace industry. Traditionally, things don't happen so quickly and in such large numbers. One of the great things about launching other people's CubeSats, besides developing our own, is you get to see a lot of different ideas and different ways of doing things. So that really gives you a lot of perspective on what's going on in the community and what people are doing, which I think is very useful when thinking about regulation and how to solve some of the problems we have. The other thing, so we have PUIG, it's a small startup, and we basically were trying to do missions that at the university, the students have this very bad habit. When they get really smart, they graduate and get really good jobs. So we decided we wanted to keep them. So the only way to keep them was to give them the good job ourselves and keep them working. And actually, I've been amazed at what you can do when you can keep them longer. Because now that they're trained and really good, man, they can do a lot in a year. I never got to see it because they would always go do it for Orbital or Northrop or some other company. But we're looking at very high-end components and very high-end missions, the kinds of things that the university could not do. Our flagship mission, the one that we're working on right now, we call it CPOD, but it's a CubeSat Proximity Operations Demonstrator. We're actually going to launch it in early 2016 because we cannot get access to space before that. But it's basically 3U CubeSats doing rendezvous and docking autonomously in orbit. So it's a lot of the things that things like Orbital Express did before, but they did it with hundreds of kilograms of spacecraft. We're doing them with 5, I think, or 5.5. So anyway, again, we run into a lot of the problems with commercial activity, and we cannot use amateur radio anymore, and we have to do things differently. So again, more perspective to see what's going on. I think the next couple of things I'm going to go really fast. For those of you who don't know, and I know there's some like regulator types, I feel I've been told that they're here. And they may not know how this CubeSat thing started, but it started in '98. It was a student project. It was really an idea to try to get student satellites flown, and it actually worked fairly well. So we launch everywhere. Everybody's doing it. And one of the things that's very important is that we have new players. There's new countries, new universities, new companies that are entering the space business for the first time with CubeSats. And that's going to play a role in their ability to do the regulation correctly because they don't have any experience working on those things before. So, and actually we're seeing the same slides over and over again. We all have the same thing, but this is just number of satellites that have been launched, and this is things that really happen, and we saw, and it's Planet Lab's fault. If you want to blame somebody, go over there. But we started to see a big change in the numbers in around 2010. Things started to take off, and it's only the very small size. The other sizes are pretty much stable. They've been launching continuously, but it's kind of a steady state. If you look at the predictions, and this is SpaceWorks again. They're predicting really high numbers. That 2013 number was right. I was looking at somebody that the RL research said that number is already too low. The 2014 number was closer to 150, I think is the number. And so it could be that we're beyond these numbers in the future. So that's a lot of satellites. That's a lot more satellites than traditionally have been launched planet-wide. And that is an issue. So who's doing it? That's another thing that's important. Who's working on these satellites? Is it, Planet Labs is doing everything, or is it everybody? And the answer is this is global. Okay? And actually there are some in Alaska and in Australia, so the circle is not big enough. But everybody's doing it. We have CubeSats in Africa, we have CubeSats in Southeast Asia, in South America, all places where you wouldn't expect satellites to be coming from. And one of the things that's very interesting, I talk sometimes about space developing nations, which is different from developing nations, because there's some highly developed countries that have never launched a satellite. Switzerland launched the first one a few years ago. Norway launched one. Australia hasn't. They're almost ready though. I've been told that they have a CubeSat ready to go. England just launched UK Cube recently. So it's an interesting mix that there's a lot of people that are very advanced but may not have space experience, and that is going to come and have an effect. And of course, there's people who are developing countries and go on satellites, and they have to deal with the fact that their country doesn't have a space infrastructure at all. We brokered the launch for Libertad 1, which was the first satellite in South America, and the first CubeSat in South America, and the first Colombian satellite. And nobody knew who was supposed to sign anything because they didn't have a space agency, they didn't have the infrastructure, and it was a very interesting process to watch. Okay. So one question, and actually this is the talk that we had right before the break. I'm doing that one again. But the basic idea is, are CubeSats a revolution or an evolution? And what we decided after thinking about it for a while, because the question was asked many, many times, is the fact that they're small is an evolutionary step. But they do have revolutionary parts. And they have nothing to do with size. They have to do with the way you build them and the way you launch them and operate them. And so you have a much higher risk tolerance, which means you accept failure in a way that the space business is not ready for. You have very flexible launches with very high numbers, low cost, short schedules, and then you use standardization. And I highlighted a few of them because these guys are the ones that affect the licensing and bureaucracy process. If you have high numbers, that's a problem for the regulators because they have to handle a lot of applications at numbers that are not what the space system is designed for. The lower cost means that it's not trivial to go hire a lawyer and say, hey, you do it, because these satellites per unit are very, very inexpensive. And the development time, again, it's not fitting with the schedules that traditional regulation processes have been working with. So that has kind of broken the system a little bit. Now, this is not new. Again, I'm back at a couple of talks earlier today. This has happened before. Survey did it. The AMSAT community has been doing this kind of thing a lot. The shuttle gas can was another place where people would try relatively quick, relatively inexpensive, different ways of doing space. The one thing that has happened with CubeSats is that we took it to a new level because of the standard.